So today on page 20, we're going to talk about the discriminant. Now, we spent yesterday talking about quadratic formula. And quadratic formula, as you'll remember, works for any quadratic equation. It is the ultimate way to solve because it works for any one of them. But you do have to have the equation in standard form. And it is best when you cannot factor it. Okay, so I might even say it might be best other times too. So if you're in a hurry, quadratic formula will work for you every time. So what we're going to concentrate on today, though, is the discriminant. Now, what the discriminant will do is it'll tell us what kind of solutions we have. And the discriminant, look at quadratic formula, the discriminant is just what's underneath the radical sign. So the discriminant, don't worry about memorizing, because you're going to know quadratic formula, and it's just b squared minus 4ac. So that's your discriminant. And it is just a small part of the quadratic equation, but it's the one that determines what kind of the number of solutions and the type of solutions. Remember that solutions and roots and zeros for now are seen as the same thing. You're not going to worry about roots too much. X-intercepts, the only difference is that you're going to have the number and then your y-coordinate is 0. But your solution would go right there. Your 0 would go right there. Okay? And you still want your equation written in standard form. So what this tells us so far is if b squared minus 4ac, the discriminant, this is called the discriminant, if it is positive, meaning that if it's greater than 0, then you're going to have a real, sorry, let me try this again. You're going to have two real number solutions. Okay? And as you found out with quadratic formula, sometimes you're going to get solutions that are nice little numbers that you can just, no big deal, but they're going to be real numbers, so you can, it might have that you have to take, like, your answer is 5 plus or minus 5, 8 square root 2 all over 8. I don't know where I was just saying, but it's going to be two real number solutions. And for now, that's all you have to pay attention to. And what we know is going to happen is it's going to hit the x-intercept 2 times. So here is an example of what my graph would look like. So I would know my 2 x-intercepts, or I would know what my zeros or my solutions were, and I could plot those. Here the only difference is, of course, a would be negative. Now, if the discriminant is 0, well, look, go back to graphing. We're going to have one solution. And it's also going to be a real number. Now, the reason we say real number is because it could be rational or irrational. We're not going to get into that in Algebra 1. That's an Algebra 2 thing. But we're going to have only one solution. Okay? That means it's going to come down. It's going to come down, hit it, bounce back right up. Or it's going to come up, bounce, and go right back down. So it's going to only touch the x-axis once. You're going to have one x-intercept. And what that means, because it's a quadratic, it has a power of 2, that means that it's going to be a double root. But again, we don't need to worry about that until Algebra 2. Now, if we have a negative discriminant, we've talked about this many times too when we solve, okay? If we have a negative under a radical, and remember this is just the information under a radical, this is just b squared minus 4ac, then it's going to be negative, and if it is negative, then we know that we have no real solution. Okay, we have no real solution. And notice if I have no real solution, it does not cross the x-axis. It just doesn't go down that far. And you might remember that when we were graphing back in section 1, when we were graphing equations and it didn't cross the x-axis, that means that we had no real solution. Okay? So, and that's all we're going to say for that. We have no real solution. We can't solve it yet. There is a solution, so it's not no solution, but it's no real solution. Okay? So let's look at what we're going to do with this. It says directions. Find the discriminant of the following problems and state the nature and the number of solutions. Then use the quadratic formula to determine the solutions and draw a quick sketch. Okay, so here we go. And I do think it's much easier if we write down what A, B, and C are. So A is 1, B is negative 8, and C is 16. So now we're going to find the discriminant. Remember, the discriminant is just b squared minus 4ac. Okay? Now we're going to plug that in. Negative 8 squared minus 4 times 1, because that's A, times C, which is 16. That gives us 64 minus 16 times 4, 64. That gives us 0. So our discriminant is 0. If our discriminant is 0, that means that we're not going to have anything underneath that radical, so we're just going to have one solution. And this even makes more sense when we plug it into quadratic formula. We're going to have one real number solution. Okay, so now here's a really good news. This is b squared minus 4ac. So when we do quadratic formula, here we go. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Well, we already know b squared minus 4ac. We just found that. We don't have to do it again. So notice what happens. We're going to plug in negative b. So we come back up here, there's b. So negative 8, okay, minus, plus or minus, the square root of, well, it's 0. We just found that. All over 2a, and a is 1. So this is the reason there's one solution. This plus or minus is this stuff back here. We don't have a plus or a minus, so we just have one solution, 8 over 2, which is 4. So that is our solution, is 4. Okay, if we want to write it in set notation, it can look like that. That's our x-intercept. Our x-intercept will be 4, 0, yada, 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 okay? But we can actually, it seems like, oh my gosh, I have to do all this work. But no, if I do it here, I don't have to do it there. Look how quick that goes. Okay, now they want us to do a sketch. So what we do is we look at this and we say, okay, does this open up or down? Well, A is positive, so it opens up. Where does it cross? It crosses at 4. So 1, 2, 3, 4. But what does it do? It actually bounces. So it's going to come down and it's going to bounce right back up. And that's our graph. That's what it means by a quick sketch. We take our solution and we see. We don't have to be any more exact. We need to know if it opens up or down. We need to, of course, mark where it crosses or where it bounces. Okay? So here we go on the next one. A is negative 5, B is 1, C is 1. So discriminant, b squared minus 4ac. B is 1, A is negative 5, and C is, I don't know what I just wrote, is 1. So I get 1 minus negative 20, that's 1 plus 20, that's 21. Okay, is that a positive? Is that greater than 0? Yes. So therefore we know we have two real solutions. Okay, so we have two solutions. So now we're going to plug it into quadratic formula and sing it to you yourself. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. So now we're going to plug in negative b. So b is 1, so I have negative 1 plus or minus the square root of 21 all over 2 times a, which is negative 5. So we get negative 1 plus or minus the square root of 21 all over negative 10. Now, are there any perfect squares in 21? Nope. So this is actually our solution, but we're going to write it out twice, just so that our brain gets it cemented in there. So this is negative 1 plus the square root of 21 all over negative 10, and negative 1 minus the square root of 21 all over negative 10. And then we're going to take out our calculators and find out what that is and round it to the nearest. Does it say? It doesn't say. But we're going to need to round it because we have to do a sketch. So we're going to have to do that. Get your calculators. So when I plugged negative 1 plus the square root of 21 all over negative 10, I got a negative 3.582575695. So obviously I'm not going to use all of that. If in doubt, I always go further places than I need to. So I would put that as negative 0.358. Okay, but you could have just done 0.36. I'm fine with that. And then when I did the other one, I got positive 0.558. Such nice numbers. Okay, but what it tells us is this, well, and it even kind of tells us, look at this graph. Look at what A is. A is negative, and it's 5. So, of course, it's going to be narrow. Okay, so that makes total sense. So what we're going to do is we're going to come down here and say, hey, here's negative 1, and here's 1, and I'm going to, oops, you can't see that. And I'm going to give it some space because we have to get that in there. So 0.3, negative 0.3 is about right there, and negative 0.5 is about right here. And this opens down, so it's going to come up like this and take a pretty sharp little turn right there and come right back down. Okay, so we just kind of give a sketch to it. Good. Okay, let's try one more together, and then we'll see where we're at. Well, why don't you try and get the discriminant? Let's pause, and you do that discriminant, and let's see what you come up with. Now, did you get a negative 32? Did you kind of guess we were going to do that? We got a 0, we got a number greater than 0, and we got one less than 0. So we kind of knew that. So this is going to be no real solution. Okay? So we plug it into quadratic form, and we're going to have negative b plus or minus, square root of b squared minus 4ac all over 2a. So we're going to have negative b, but does it matter? Because look, write it down though. Plus or minus the square root of negative 32 all over 2 times 8. Okay? So we have a negative under a radical. Algebra 1, we don't get to solve it yet. So we just go to no real solutions. Or we say not yet, meaning we don't get to solve it yet. So we can also just write not yet. We don't get to solve it yet. So now you're like, how much the heck am I supposed to graph this? Well, it's going to be narrow. We don't know where it's going to turn around, but we know it's not going to hit the x-axis. So you're going to just come down here and just draw a little sketch that goes up like this. Now that's way too wide. This one's going to go way narrow. So it's going to go something maybe like this. We don't know. We don't know any more about it other than it does not touch. So your sketch of this is just saying, hey, it's not going to touch, and it's going to open up, and it's going to be narrow. You could have drawn one like that, one like this. That would have also been right. So when we're talking about sketches, but we're just trying to get you to have the idea of what could it look like. It can't open down. I mean, you can draw all kinds of little ones on here, and it doesn't really matter. Okay? So this is great because we've seen an example of every single one of these, one solution, two solutions, and no solutions. So what I'd like you to do is for homework, well, I'd like you to check with your teacher. So they might have you finish this packet and then go to page 91 and do, 91. How about, well, this is interesting. It goes from 30 to 37. You can tell I'm the one numbering this. So anyway, check with your teacher what's going to be your homework. I'm guessing possibly finishing this, maybe doing some on here. Now here it just says what's the discriminant. So you're going to find it. Then it says how many solutions, but I would recommend that you actually state what kind of solutions. And then you're going to list what the solutions are. So here you're going to plug it in. So you're going to do everything that you did here, except for you're not going to have to sketch it. So you're just doing this and stating just like we did here. Okay, so make sure you go out to Schoology, check exactly what your teacher wants you to do for homework, but that is the discriminant. So if you have any questions, you know where to find us. Thank you.